viewers, welcome to ChemSpark. I am Blessing David and I'll be your tutor for this lesson. Now imagine this. On a hot day, you put an ice cube in your mouth. At first, it is hard and cold, but over time, it melts and runs down your throat. Also, when water is boiling in a kettle over time, it slowly disappears as steam. I have two questions to ask you. Are the water, the ice, and the steam different? Or is it the same thing behaving differently? That brings us to our topic for the ChemSpark lesson of today, which is the kinetic theory of matter. The kinetic means motion. From kinetic energy, we know that it is the energy in motion, and therefore the kinetic theory of matter, it explains that the particles of matter are in constant motion. They are constantly moving. It is worthy to note that Daniel Bernoulli is the father of the kinetic theory. Now I'm going to be running through the postulates of the kinetic theory of matter. The first postulate states that all matter is made up of tiny particles, which are the atoms and the molecules. From our previous lessons, I know we, the viewers and subscribers, we all know this already. We know that matter is made up of tiny particles, which are the atoms and the molecules. The second postulate states that these particles, that is the atoms and the molecules, they are in constant random motion. I've stated that earlier. They are always moving. Now we know that atoms are very tiny, and that is why we do not notice the movement, but they are always in constant random motion, and they possess kinetic energy, that is energy in motion, which increases as the temperature increases. And that is why when you are boiling water, you would actually see the particles moving. That is what this last line is trying to say. It means the particles possesses kinetic energy, which increase as the temperature also increase. Moving further, the third postulate of the kinetic theory of matter states that there exists a force of attraction called the intermolecular force of attraction, which holds the particles together. The intermolecular force of attraction is what holds the particle of the matter together. Then lastly, the fourth postulate of the kinetic theory of matter states that there are gaps between these particles called the intermolecular space, and that allows the change of state and also compressibility. Change of state in the case of water, when it is ice, it is solid. When it is water, it is in the liquid state, and when it is steam, it is in the gaseous state. It is because of the intermolecular space that allows for this change of state. Because now that space, now when you actually boil the water, there is a change of state and the movement is rapid, it increases. Alright, to conclude, I'll go through what I've said again. Our topic for today is the kinetic theory of matter, and we state that the particles of matter, which are atoms and molecules, they are in constant motion. They are always colliding with each other, and I believe we have known from our previous lessons how matter is the solid, the liquid, and the gases, how they are. Now, we have stated the postulates of the kinetic theory of matter, and I believe with this lesson of today, we can look at water boiling and understand what is happening there. When water freezes into ice, we can look at it and understand that, okay, there is a reduction in the temperature, or the temperature is being lowered, which results to this change of state. All right, thank you, and don't forget to like, subscribe, and you can click on the notification button so as to be reminded when next we have another video. Thank you.